Good morning, lovely 12s. Right, guys, it's our last online lesson for a little while, thank goodness. So if you could put the title for me, Areas Between Lines and Curves, that would be brilliant. We are going to finish off the integration unit today. Hopefully you'll get a practice lesson after this one, but yeah, finishing off the integration unit today. And yeah, here we go. Okay. So here's the skills that you guys know so far with integration. You know, number one, it reverses differentiation. You know, number two, that you can do definite integrals, actually giving out values. You know, number three, that you can find the area between a curve and the x-axis, and that's what we did last lesson. And the final thing that we're going to learn today is you can find strange areas, like this little yellow bit up here. And all it involves is a little bit of problem-solving skills, and we'll be flying. Cool. So let's jump right in. Okay. Question one says this. The diagram shows a sketch of part of the curve with this equation, x brackets 4 minus x, and the line y equals x. Find the area of the region bounded by the curve and the line. So it's after the yellow bit, and yeah, it's after that yellow bit there, and we just need to work out what that is. Okay. I think I'm just going to kind of tell you guys what the strategy is here. Here's the skills that you know. You can find the area between this curve here, and the axis, right? If you were to find that area, though, you see it would cover all of this. Do you see what I mean? Like, you could go from that point there, and you could get that entire area, but that area is too much, because we'd have to get rid of this area, too. Okay, have a good look at it right now. What do you think we have to do? That's right, buddies, if you manage to spot it. If you manage to spot it, that's very good. But here's what you can do. If you find the area that's underneath the curvy line, so this is this, all the way down to there, all the way down to the floor, all you have to do then is subtract away this triangle here, and you will have the area that you desire. So that's what we are going to do. That's precisely what we're going to do. So to start with then, yeah, we're going to want to integrate to get the area under the curve. That's number one. Yeah, let's try it. Here we go. So let's get the area under curve. Area under curve. Right. Now, here we go. Straight away, if you want the area under the curve, we know that we're going to be integrating. And we know for sure we're going to start at 0. But are we going to go all the way to 4? Well, no, actually, because we don't have to get from there all the way to there. We only have to get to here. We need to get to this point here, which I'm going to call, oh, I don't even know. Call it, I can't call it A because I just called the other thing A. Call it B. Okay, sweet. So we just need to get to B, right? We need to go between 0 and B. But I don't know what B is. So here's what we got to do first of all. We have to get that point. We got to get B. Because say that, like, that point B, say the x-coordinate of it was 3, then we'd integrate between 0 and 3, for instance. So that's number one. So first step first then, before we can do this, the integration, is we need to get the point of intersection. Get the point of intersection. Cool? Because it's going to be where the line hits this curve. So we've already given what the two equations are. We know that one is x bracket 4 take x, and we know that the other is just y equals x. So if we're after the point of intersection between those two, we're simply going to equate them because they both start with y equals. So in other words, the left-hand one, x bracket 4 minus x, will equate with the right one, I mean, which equals x. So here we go. 4x minus x squared equals x, let's move the x squared to the other side, 0 equals x squared when that goes over, and this is going to be minus 3x. Oh my god, I guessed it right. 0 equals x bracket x minus 3, which means that x is 0, which we can observe, and also x equals 3. By god, I'm a good guesser. And also x equals 3, okay? Well, both of these answers are right. There's the 0. There's that one spot where it crosses. And this spot's 3. Shaboosh. 3 is what we wanted. Does that make sense, everybody? Do I care what the y-coordinate is? Do I actually care what the b is as a coordinate? Do I need this ordered pair? Nah, we only need the x values because we're just integrating. So, yeah, let's do it. So it's going to be between 0 and 3, the area under the curve. Everyone happy? Good. And the thing we're integrating is actually the function itself. It's the x bracket 4 minus x. So I'm just going to rewrite that as 4x minus x squared. Not forgetting the dx, because that integral sign is meaningless without it. Okay, so let's do it. So here we go. A equals square bracket now, 4 is chilling, x squared over 2 raised to the power by 1 divided by the new power, minus x raised to the power by 1, 3 divided by the new power 3. Do I need a plus c? Nah, because I'm doing a definite integral. The c's would just cancel out, so may as well not bother with them. So here we go. A equals, and I made a mistake last time. I'm going to be so careful in the calculator this lesson because I made a mistake last time. So here we go. 4 brackets 3 squared over 2 minus brackets 3 cubed over 3 close brackets. Take open circle bracket, lower limit in, 0 minus 0, which is great. Okay, now being super careful, I'm not typing it wrong this time. Actually stop skipping steps 4 times 3 squared divided by 2. And that's going to be minus, this is just going to be 9 after I just said that I wouldn't skip steps. Minus 9, and that it gives an answer of 9. So A is equal to a 9 is what I've got. 4 times 3 squared. Yep, 4 times 3 squared all over 2. Take away 3 cubed divided by 3. So 3 times 3 is 9, 27. By 3 is 9. Yeah, perfect. I'm happy with that now. Sweet. Okay, so the area equals 9. So in other words, this entire area equals 9. Cool beans, buddies? Right. So if the whole entire area, actually I'm going to shade that with yellow. If the entire yellow area is worth 9 altogether, all you need to do now is take away this lower rectangle, or this lower triangle that I don't care about. Okay? Now, you can find the area between curves, but actually, when it's like a straight line like this, they always either make triangles or trapeziums, and we can just bish bash bosh out our formula, either half base times height for a triangle, or half the sum of the parallel sides times the distance between them for a trapezium. So here we go. How wide is the bottom of the triangle? Well, it's 3, because it spans from 0 to 3. How tall? Oh, after I told you we didn't need to work out how the coordinate was, we actually do. How tall is it? Well, don't know yet. That means we do actually have to have the coordinate after I told you I didn't. Well, the x value is 3, right? But that doesn't help us with how tall it is. But fortunately, the equation here with the 3 is actually just y equals 3, or like y equals x, which means that y equals 3. So this coordinate is actually 3, 3. Debacle. So that's a 3 as well, which means the height of this thing's 3 too. And that's it. So area under the curve is that. Area of the triangle now, so let's just squeeze that in here. The area of the triangle, well, it's just going to be this. It's going to be A equals a half times base times height. So half of 9 is 4.5. So A equals 4.5. 9 take 4.5 is going to be your final answer. So yeah, the shaded bit then, shaded, is just going to be area equals 9, take 4.5, area equals 4.5. Like an absolute beast. You've just done your first ever area under a curve. I know it's a little bit more complicated, but actually it is just problem solving skills, I'd have said. So I've not taught you anything new today. I've just made you do some problem solving skills. Is that cool? Okay, good. They can get harder, unfortunately. So let's try a harder one. Let's go. Okay, this is harder. Now, if you feel good, I would say, like if you followed that, no problem. If anything, if I was going a bit too slow for you, I would say go ahead, whack it on pause and see if you get the right answer. So if you feel good, do it. Pause. But if you don't feel good, here we go. Let's do it together. This one says, diagram shows the sketch of a curve with this as its equation. And the align with equation y equals 2x. So there's our picture done nicely for us. Find the area of the region OAC. Okay. Even if you've not paused, even if you're waiting for me to do it with you, can you see the two shapes? Can you see the triangle in the part of the curve that's going to be of interest to us? If I'm after that yellow area, can you figure it out? Have a little think. Well, if you said that a really useful triangle would have been this one. Oops, not with the eraser, with the actual drawer. This triangle here, if you did a triangle all the way out to C, and then down, and then across. If we could find that triangle, buddies, get the entire area. So it's like the same as the other one, but backwards. This time we'll do the area of the triangle first. It's the bigger area this time. If you can find the area of that big purple triangle, well, you can then find the area under the curve here. Cool, by doing integration. And then all you have to do is take the big purple triangle and then take away from it the little purple area under the curve. Does that make sense, guys? Okay, well, let's do it then, my buddies. For sure, what are the things that we're going to need to have? Well, we're going to have A and B, because, well, to begin with, I don't know how big the base of the triangle is. I don't know what B is. I don't know how tall the triangle is. I don't know how big. I don't know how tall the triangle is. I don't know how tall C is, and I also don't know where to integrate between, because I don't know what A is. So I'm going to have to integrate between A and B. So I need two things then. I need to know A and B, and probably C actually as well. So yeah, let's get those coordinates. You ready? Cool. How are we going to get A? Let's get those coordinates sorted. Let's get A first. Get A. How are we going to get that coordinate A? Well, if you look at A, you can see the special thing about A is it's where the curve crosses the x-axis, yeah? There's two spots where it crosses, one at O and one at A. So, what's that telling you? Well, it wants you to say where the equation, where I've got in yellow up here, it wants you to say where that equals 0, right? Because that's what defines A. So here we go. It's going to be 0 equals x bracket x minus 3. Get it? Because it's like the roots. You got it. Okay, so that means x equals 0, which is the one that we already see on the picture, and x equals 3 again. Cool. So that means, my buddies, that this A in this here is actually a 3. Cool beans, buddies? Yeah? Cool. That's cool. Right. How are we going to get B then? Well, let's try it. Let's get B. B is special because it is directly underneath the point of intersection. So in order to get the point of intersection, we need to, in order to get B and C, to be honest, we need to get the point of intersection. So we need the POI. Need point of intersection. Well, if you're after the point of intersection, buddies, you know how to do that. Set them equal to each other. Let's do it. X brackets x minus 3 is going to this time equal to x. So x squared minus 3x equals to x. So we're going to get x squared minus 5x equals 0. Never ever divide by x though, right? Because you lose a solution. So we'll factorize x bracket x minus 5 equals 0. So in other words, this guy should have a point of intersection where x equals 0 and also where x equals 5. Now both of these are sensible. They do have a point of intersection at x equals 0. See? It's there. And here's the other one. It's x equals 5. So actually, if they intersect where x equals 5, that means the x-coordinate of C is 5. We don't know the y-coordinate yet. But for sure then, because B is right underneath C, B is 5. Cool? It's just problem solving. I really like it. It's good. It's problem solving. Let's get C just for good measure, because I think we will actually need to know the height of the thingy, of the triangle. We'll have to know the height of the purple triangle. So here we go. Pick whatever equation's easier. Y equals 2x, because we're just solving the point of intersection now, which means y equals 2 times 5. Y is 10. So the point then of C is 5, 10. So 5, 10, boom. You've got everything you need now to solve this. We're ready to go and right for the crushing answer. Yeah, wicked. Let's do it. Okay, you ready? Big triangle. Let's do the big area first. Big triangle. Well, the triangle is just a regular old shape, right? So it's just a half times base times height. How big is the floor of the triangle to go from 0 all the way to B? Well, 5. Yeah, because that's the x-coordinate there. It means the whole length must have been 5. How tall is the triangle? Well, from the floor up to there, well, it's 10. So the area of the big triangle is a half times base times height, a half times 5 times 10. Cool. Half of 10 is 5, 5 times 5 is 25, so the area of the big triangle is 25. Cool. Now, that's the easy part done. Now, for the hard part, the actual things that you have to do for this year, we need to get the blue area, okay? So we need to get the shaded area, the area under the curve. Yeah? So get blue shaded area. Shaded under curve. Under curve. Okay. Now, the curve that we're integrating then, it is under the curve, not under the line, it's under the curve, which means the curve was what I highlighted here in yellow. It's the x bracket x minus 3. So that's what we're integrating, okay? So here we go. It's going to be the integral of, and I'm just going to change colors, don't like it all being in red. It's going to be the integral of x, what was it again? X minus 3? X minus 3 dx. I think that's right, I'm just going to check. Yep, x minus 3 dx. Perfect. Don't forget the dx is meaningless without it. And what are we going between? Have a little think. Look at the picture. What am I integrating between? That's right, guys. 3 and 5. The reason it's 3 and 5 is because this is the section of curve that I care about. This bit. Which means that I'm going between 3 and 5. Which means I'm going to have to be really careful with my calculator in a minute. But yeah, 3 and 5. From 3 to 5. Lower limit 3, upper limit 5. Cool. Sweet, let's bish bash wash it through. It's not ready to go yet, so here we go. 3, 5, x squared minus 3x dx. Okay, sweet, and let's do it. Square brackets now. I'm going to put an A in front for area. A. Okay. Raise the power by 1, x cubed divided by the new power, 3 minus 3, because it's chilling. Raise the power by 1, squared over 2. Close the square bracket, 3 and 5. Okay, pop in your limits. A equals, open circle bracket, 5 cubed over 3. Should have a bracket, so I'm going to do it anyway, even though I don't need it. Minus 3 brackets, 5 squared over 2. Close circle bracket. Take away, open circle bracket, and this is where I'm going to have to be careful putting it in. It's going to be open bracket 3 cubed over 3 minus 3 bracket 3 squared over 2, close circle bracket. Now, with the such care, type this into your calculator super carefully. I've not pre-typed it in yet, so I'm going to do it right now. And yeah, you guys do it right now too. Here we go. So 5 cubed. 3 brackets, 5 squared, 2, close major bracket, open little bracket, oops, 3 times 3 squared over 2. I'm mortified I'm going to type it in wrong, so I made a mistake on the last video. Oh, good heavens. Okay, I got 26 over 3, so I hope that that's right. I'll check in a sec. 26 over 3 is what I got as that area. Okay, sweet. So, yeah, you got the big triangle. You got the little shady bit underneath. So now we're just ready to get the total area, like the final answer. Cool, so left over, or shade, I'm not right, left over, right, shaded. The shaded area, which is what it actually asked for, is just going to be the two differences, isn't it? So it's the big triangle, which was 25. So let's do it. A equals 25. Take away the curly bit, 26 over 3, because that was 26 over 3, don't forget. Cool. 25, take ants equals 49 over 3. Oh, no mistakes this time. Love it. 49 over 3. And bang, final answer, you got it. I would say that that's kind of a hard one. They can go a little bit harder still, but I don't want to do like a million different examples for you, so we'll leave it there. There's some in the mixed questions for you to try. There's some that are proper sneaky and tricky, so I'd try a couple where it actually tells you what the area is and you have to work backward. That's certainly worth a try. And so are the ones where sometimes the area bit's above the curve. That's a bit weird as well. It's not always a triangle as well. See the purple there that's a triangle? There are going to be some where it's a trapezium, okay? Because that's just the nature of these guys, that if the curve was up or you had a horizontal line, you can get a trapezium too. So just look out for a geometric shape. So check your questions for a geometric shape, triangle or trapezium usually, and then find the part of the curve that you'd either like to add in or delete. And that's it. So here you go, guys, for the last online lesson for a bit. Have a go at them, guys. Page 304, question 1 to 11, do a mix, just as I say. Like I just told you, the ones that would be good to have a punt with. So do try a couple of tricky ones in there as well. And that's it from me. I shall see you next week, and that's it. See you later. Bye, buddies.